Aston Martin is being linked to a 2.5-second pace gain, and if that number is even close to real, Formula One's slowest team could be about to trigger the most shocking turnaround of the season. But here is the part nobody can ignore. Adrian Newey has not confirmed the number. What he has confirmed is a major new version of the AMR26 for Hungary, with a lighter chassis, a lighter gearbox, a new nose, revised aerodynamics, and structural changes serious enough to require another crash test. This is not a normal upgrade. Aston Martin is last in the Constructors' Championship, with only 1 point and 10 retirements. Fernando Alonso finished 19th at Spa, 2 laps behind the winner. Lance Stroll did not even reach the finish. Now, Newey is trying to fix the rushed foundation of the entire car in one decisive move. And the most important secret is not one hidden wing. It is how every change connects. Because if the new design unlocks the performance trapped inside this car, Aston Martin will not just gain lap time. It could save Alonso's future, rescue Newey's project, and completely change the order of the grid. But if it fails, the team may finally run out of excuses. To understand why this upgrade matters, you have to understand how badly Aston Martin's season has gone wrong. The team entered 2026 with almost everything Formula One fans had been waiting to see. Adrian Newey had arrived. Honda had become the factory power unit partner. Fernando Alonso was still searching for one final chance to fight near the front. And the new regulations were supposed to reset the entire grid. On paper, Aston Martin looked ready to become one of the biggest threats in Formula One. But the reality was the exact opposite. By the time the championship reached Belgium, Aston Martin was sitting 10th and last in the constructors' standings. 1 point. That was all they had scored across the entire season. And behind that single point was an even more alarming number. 10 retirements. That means Aston Martin was not simply struggling for speed. The team was struggling to complete races, gather clean data, and build any kind of momentum. And this is where the story becomes much more serious. Because a slow car can sometimes be fixed. A car with one weak area can be improved. But a car suffering from weight, reliability, vibration, power unit integration, and aerodynamic inconsistency at the same time is not dealing with one problem. It is dealing with a chain reaction. Think of a row of falling dominoes. The first mistake may look small. But once it falls, everything behind it begins collapsing. For Aston Martin, the first domino was time. The team did not begin serious work on the 2026 car until the middle of March in 2025. The first wind tunnel model did not arrive until the middle of April. By then, several rivals had already been working on their own concepts for months. That delay changed everything. Formula One teams do not build a new car by simply choosing a shape and sending it to the circuit. They test thousands of ideas. They reject weak concepts. They refine tiny details. They reduce weight one component at a time. They study how the engine, battery, cooling system, chassis, suspension, and aerodynamics all affect each other. And that process takes time. Aston Martin did not have enough of it. Newey admitted the team started several months behind. That may not sound catastrophic. But in Formula One, several months can mean the difference between arriving with a finished concept and arriving with a car that still needs to understand itself. Imagine being asked to build a house while everyone else has already completed the foundation. You may have better ideas. You may have more talented people. But if you rush the first stage, every later decision becomes harder. The walls depend on the foundation. The roof depends on the walls. And once the structure is complete, fixing the beginning becomes painfully expensive. That is exactly what happened with the AMR26. The car was designed under pressure. And Newey has been brutally honest about the consequence. Weight was one of the first areas to suffer. The chassis became significantly heavier than Aston Martin wanted. That problem was made worse by vibration issues connected to the integration of Honda's new power unit. And this is the detail most people overlook. Extra weight does not only slow a car on the straight. It changes almost everything. The car takes longer to accelerate. It takes longer to stop. It becomes slower when changing direction. The tires are placed under more stress. The suspension has to control more mass. And the driver has to fight a machine that feels less responsive in every phase of the corner. It is like running while carrying a heavy backpack. You can still move. You can still push. But every step costs more energy. Every turn feels slower. And over a full distance, the burden becomes impossible to ignore. That is why the rumored pace gain has attracted so much attention. If Aston Martin can remove a meaningful amount of weight, the benefit is not limited to one area. The entire car begins to breathe differently. But weight was only one piece of the failure. The Honda integration created vibration problems. And vibration inside a Formula One car is far more dangerous than it sounds. These machines are packed with almost no wasted space. Cables, cooling systems, structural parts, battery components, and power unit elements are squeezed together as tightly as possible. If one area vibrates more than expected, other parts may need reinforcement. Reinforcement adds weight. Extra weight changes balance. Balance changes suspension behavior. Suspension behavior changes the way the floor interacts with the track. And suddenly, one problem deep inside the car is affecting the airflow outside it. That is the hidden reason the AMR26 became so difficult to fix. The problems were connected. Aston Martin could not simply replace one part and expect the car to transform. Every solution had the potential to create another compromise. And by the opening race in Australia, Newey said the team finally received its wake-up call. That statement tells you how far behind the project had fallen. The first race of the season effectively became one of Aston Martin's first meaningful opportunities to understand the car on track. The team was still learning what it had built while its rivals were already racing, developing, and moving forward. And the situation did not improve quickly. At Spa-Francorchamps, Fernando Alonso finished 19th. He was 2 laps behind the winner. Lance Stroll retired after only 25 laps with another issue on the AMR26. That weekend captured the entire season in one image. One car reached the finish, but far from the fight. The other did not reach the finish at all. And this is why Hungary has become a must-deliver moment. Not because Aston Martin expects one upgrade to erase every mistake. Not because 2.5 seconds has been officially promised. It has not. But because the team is finally attempting to correct the rushed foundation of the car. The lighter chassis. The lighter gearbox. The new nose. The revised aerodynamic surfaces. The changes at the rear. These are not isolated pieces. They are part of one larger attempt to make the AMR26 function as a complete machine. And that is where Newey's real design philosophy begins to appear. The secret is not one magical wing. It is the relationship between every part. A lighter structure helps braking and acceleration. A new nose changes the air reaching the rest of the car. Better airflow helps the floor generate grip. A revised rear suspension can make the platform more stable. And a more stable platform allows the aerodynamics to perform more consistently. One improvement opens the door to another. Then another. Then another. That is how a large gain becomes possible. Not because one component finds 2.5 seconds, but because several major weaknesses are finally being attacked at the same time. And yet, there is still one dangerous question. What if the first car was not simply unfinished? What if the basic concept itself is wrong? Because if that is true, Hungary will not be the beginning of a comeback. It will be the moment Aston Martin discovers that even this enormous redesign is not enough. And this is where the upgrade stops looking like a normal Formula One update. Aston Martin has not simply changed a wing. It has not added one new floor edge and hoped for a miracle. The team has gone deeper. Much deeper. Adrian Newey confirmed that the main chassis and gearbox architecture will remain in place, but Aston Martin has taken weight out of both. That distinction matters. The car is not being replaced completely, but the structure beneath the visible bodywork has been revised enough to require another formal approval process. The forward section of the chassis had to be rehomologated. It also had to pass another crash test. And that tells us something important. This was not a cosmetic change. Aston Martin altered the car deeply enough that it had to prove the revised structure still met Formula One's safety requirements. That does not mean the original car was illegal. It does not mean the sport's governing body launched an investigation. It means the team changed a safety-critical part of the machine, and before that new version could race, it had to pass the required checks again. Think of it like rebuilding part of an aircraft. You cannot simply say the new version should be safe. You have to prove it. And this is one reason the package could not appear immediately. Every major structural revision takes time. The parts must be designed. They must be manufactured. They must be tested. And if they fail, the entire process can be delayed. That is the level of risk Aston Martin accepted to bring this package to Hungary. But the lighter chassis is only the beginning. The gearbox has also lost weight. The rear suspension has been slightly revised. The front suspension remains unchanged. A new nose has been developed. And the aerodynamic surfaces have been substantially reworked. Those words, substantially reworked, are crucial. They suggest Newey is not trying to repair one isolated weakness. He is trying to change how the air moves around the entire car. And the nose is where that story begins. The nose of a Formula One car does much more than hold the front wing. It helps decide where the air travels next. Some air is guided around the front tires. Some is directed toward the floor. Some moves toward the side pods and cooling openings. If the airflow becomes messy at the front, every part behind it has to deal with that disorder. Imagine pouring water into a narrow channel. If the entrance is clean and controlled, the water flows where you want it. If the entrance is badly shaped, the water breaks apart, spills outward, and becomes harder to manage. Air behaves differently from water, but the basic idea is similar. Control the flow early, and the rest of the car has a better chance of working. Lose control at the front, and the damage spreads. That is why a new nose can affect far more than the appearance of the car. It can change the quality of the air reaching the floor. It can change how the side pods manage the wake from the front tires. It can change how stable the car feels when the driver turns. And this is where the lighter structure becomes part of the same story. A lighter car moves differently. It changes direction with less effort. It places less demand on the tires. It can respond more sharply under braking. But that sharper response is only useful if the aerodynamics remain controlled. If the car becomes lighter but the airflow remains unstable, the driver may simply receive a faster version of the same unpredictable machine. Newey's challenge is to make both improvements work together. Less weight, cleaner airflow, better platform control, more consistent grip. That is the chain. And one weak link can still ruin it. The rear suspension revision may seem small compared with a new chassis or new nose. But small suspension changes can have a major effect on how the car behaves. The rear suspension helps control what happens when the driver brakes, turns, and accelerates. It affects how much the rear of the car rises or falls. It affects how the tires remain in contact with the track. And most importantly, it affects the height and angle of the floor. That matters because the floor is one of the most important sources of grip on a modern Formula One car. The floor works best inside a specific range. Too high, and it may lose performance. Too low, and the airflow beneath the car can become unstable. If the rear of the car moves too much, the aerodynamic balance can shift from one moment to the next.